Hello, today's lesson is on the advanced use of the equations of motion. I suggest you get out a pencil and paper and calculator because I'll be asking you to do a few calculations as we go through it. Now, the equations of motion that we're going to use are the same ones that you have been using. So no new equations. In fact, technically, there really isn't anything new at all. We're just going to use what we know to answer some very thorny, hard problems. So I'll help you out with some of those. The first category of challenging problems is ones that involve positive and negative signs. Now, if you remember, the positive and negative simply means which direction it's pointing. So a positive velocity might be going to the right, whereas a negative velocity goes to the left. And the same for acceleration. If you're accelerating to the right, it's a positive velocity. Acceleration to the left is a negative velocity. So we're going to use these. So sometimes it's pretty critical to get these signs right when you're doing a problem. And I want to give you an example of that. So suppose you throw a ball straight up in the air with an initial speed of 35 meters per second. The acceleration due to gravity on Earth points downward at 9.8 meters per second squared. And after 7 seconds, how high is the ball? So the naive student might do something like this. She'll write down what she wants, which is x, and then write down what she knows. She knows the initial velocity, the acceleration, and time. And then from there, she can use a motion equation to get her answer. And that's all well and good. The problem is she's made a minor mistake if you look carefully. She told me that the initial velocity is positive 35 meters per second, so pointing upwards. And then she said the acceleration is 9.8 meters per second squared, also positive, which means it's accelerating upwards. And that's not what's actually happening. So her answer is not going to be correct, even if she does all the algebra right. Now, some of you astute students might have noticed that she skipped an important step, just to draw a diagram. So if we draw a little picture of the ball and we put some arrows on it here, the initial velocity is 25 meters per second upwards, and the acceleration is 9.8 meters per second squared downwards. I suggest that to keep track of plus and minus signs, that you put an arrow kind of off to the side and label it with a plus, and that will help you keep track of which way is positive and which way is negative. And I just arbitrarily chose upward as the positive direction because that just kind of makes sense to me, that having up is positive. So now let's try doing this again. Write down what we want and what we know, and now since velocity and acceleration are pointing in opposite directions, the velocity is a positive number and the acceleration is a negative number. And then from there on in, everything works beautifully. And you can go and verify this for yourself if you want to pause the video. I should note, we're getting a kind of an interesting result. So 35 meters per second is about 70 miles an hour. That's a heck of a throw. So the ball should be going very, very high. And yet our final answer is only 4.9 meters, which isn't all that particularly high. And what's happening is that the ball goes up, reaches maximum height, comes back down, and it's almost back down where it started after 7 seconds. So it's on its way down, and that's why it has such a small position. So let's tackle our next kind of problem, which is the generalized ball toss upwards. And a couple of very common questions that I and physics teachers everywhere will ask about this scenario is, if you throw a ball upwards, how high will it go? And how much time will it spend in the air? So let's do it. So you toss a ball up in the air with a speed of, well, say 20 meters per second. Gravity causes objects to accelerate downwards at 10 meters per second squared. You notice in the previous problem I used 9.8, but 10 is pretty close to it, and 10 is just an easier number to work with. So we'll approximate it as 10. So let's calculate the maximum height. I've drawn a little diagram here. I've declared up to be my positive direction, and then I'll make a list of what I want, what I know. I want to find x, which is the height here, and I know the initial velocity is 20 meters per second, and the acceleration is negative 10 meters per second squared, so I'm not going to make the same mistake we did last time. And then we're kind of in trouble because we only know two things, and we need to know three to get the motion equations to work. And the key insight here, well, see if you can think of it. We need to have one more thing. All right. When the ball reaches its highest position, what has happened to its velocity? It started off with a big velocity, and as on its way up, it's slowing and slowing and slowing. At the very tippy top, its velocity has disappeared entirely. So the final velocity is 0 meters per second. Once we know these three things, we can use a motion equation to calculate the maximum height. And you can go ahead and do this for practice here, and you should be getting 20 meters as a maximum height. I know that seems like it's just the same as the initial velocity. That's a coincidence for this particular problem. So go ahead and see if you can get that. All right. Now let's tackle the second part of this problem. We want to calculate the amount of time it spends in the air. So we write down what we want, what we know. We use our same diagram. We know the initial velocity is 20 meters per second. Acceleration is negative 10. There's two ways to go about doing this. When the ball is thrown upwards 20 meters per second, it goes up and it comes back down. How fast do you think the ball's going when it comes back down? If you answered 20 meters per second, you are correct. And what direction is it going when it comes back down? Well, downwards, which means its velocity is negative 20 meters per second. So we can put that in as a third thing we know, that the final velocity is negative 20 meters per second, and we can solve it that way. That's one way of doing it. There's another way. We could simply say, okay, how much time does it take to get to the tippy top? We know at the tippy top, the final velocity is 0. So we can use our motion equation to solve for that. Now the time that it takes to get up to the top should be the same as the time that it takes to fall from the top back down. So we use our motion equation to figure out how much time it takes to get to the top, and then we double that time for the total time in the air. Either way works beautifully. So go ahead and use your favorite method, or use them both, and verify that the time is 4 seconds. And that's it. Have a good evening.